So in the prior video, I presented the graph of the cosine and sine for each sigma and compared it, and we saw the x pattern, forming and its conversion into the central critical line around that area. And so now I'm doing the modulus, or the distance between cosine and sine, and sigma said that it's in the critical line or around the critical line in which the modulus is the lowest. So that's kind of what is expected, is the modulus to be at its lowest, the distance between cosine and sine to be at the lowest in the critical area. So that the that's where the zeta functions are, non-trivial zeros, closest to zero. That's actually by definition. So I generated those outcomes, the modulus outcomes for each sigma given each t, and also given the n terms. So we now have we generate files for each chosen n term. And for me, I chosen 9, starting from n equals 1000 up to n equals 10 million. The 10 million took like over a minute per loop, or like 43 minutes. 1 to 100,000 just took like an instant. It was instant. And then there was delay after the 100,000 in terms, because the UDF has to calculate that many times inside the function. And so now we see it different, but still kind of looks similar to the previous graph. But it's not now an x, there's now like a base forming. So like each of the, at the very extreme end, the left side, we see it really of the critical line. We see that it's really higher outputs. We see it ranking really high, like almost all of the rankings are the same. That it's always really high if it's a negative sigma value. But then the positive one is the one that's a bit more complicated. So it forms a V with the lower ceilings in the middle. So we do still see some symmetry. It still forms a V. There's still a convergence towards the middle. But as we increase the terms, especially as we increase the terms, the positive sigma started becoming, outputting lower modulus. So, but the range, well, that is true, especially if we increase the n terms. But it's not consistent. So it can output, it can rank number 1 as the smallest modulus, but it still has that higher range. We still have a high ceiling. That's why there is a V forming. And while around the critical area, especially critical line, has an increasing ranking, its rank is still around the middle. At first it was like 1 of the lowest, like 8, but then there's around on the right side, around a bit higher than the sigma, 0.5. On the positive side, it sort of gave off like a lower average, but around the critical line is still where we have like an average output, but has one of the lowest ceiling. Actually, that's why it's forming a V. So this one still presents it shows a bit more complicated, that it's not always the lowest, but it still converges in the middle. There's still a proof of symmetry converging into the middle or the critical line.